Hello everyone, it's December the 9th. Alright, let's do this. Count the number of computer unlocking permutations. Complexity. N locked computers in a room with labels from 0 to n-1, each with its own unique password. The password of the computer I has a complexity of complexity I. The password for computer labeled 0 is already decrypted. All other computers must be unlocked using it, or another previously unlocked computer. Following the information, you can decrypt the password for the computer I using the password for computer J, where J is any integer less than I with a lower complexity. To decrypt the password for computer I, you must have already unlocked a computer J such that J is smaller. Isn't these two saying the same thing? You can decrypt the password, or to decrypt the password using the password. So you can use a J to decrypt it, but J must be smaller than I and with a lower complexity. This is to decrypt for computer, you must have already unlocked. Oh, this is just saying J must be unlocked already. Find the number of permutations that represent a valid order in which the computers can be unlocked, starting from 0 as the only initially unlocked one. When a mod, the password for the computer with label 0 is decrypted, and not the computer with the first position in the permutation. Oh, you have two steps: decrypt the password and unlock. You can decrypt the password using the password for computer J, where J is an integer with a lower. So if the password, to decrypt the password for I, you must have already unlocked the computer J. So you have to unlock computer J to decrypt the password. And a decrypted password can unlock a computer, right? A decrypted password can unlock a computer. The password for computer labeled 0 is decrypted, and not the computer with the first position in the permutation. Which means the first one might not be. What are we returning in which the computers can be unlocked? Okay, so complexity is this. Unlock computer 0. Unlock computer 1. Unlock computer 1 with a password of computer 0. Unlock computer 2 with a password of computer 1. Or 021. Unlock computer 0 with the first root. Unlock computer 2 with a password of the first. And unlock computer 1 with a password. So you can unlock a computer if you have already unlocked. So we can always unlock computer 0 first, right? Computer 0 will be unlocked. But if I don't unlock computer 0, how are you going to unlock anything else? Because it says to decrypt the password for computer I, you need to have an unlocked computer. And at the beginning, none of the computers are unlocked, right? None of the computers are unlocked. So if you want to decrypt just one, and I still don't understand why you have these two. These two look the same to me. You can decrypt the other things to decrypt. It says you can decrypt the password for computer I using the password for computer J, where J is an integer. So this is the possibility. So for any computer, you can use a lower index computer if its complexity is smaller. So any one of those can be used to decrypt, right? But to actually decrypt it, so in a situation like this, right, 0, 1, I think this is to explain this situation. 1, 2, 3, right? So this 3, it can be decrypted by this or by this. That's the first one. You can decrypt the password for computer I using the password for computer J, where J is any integer less than I with a lower complexity. However, that doesn't mean this can be decrypted, because in order to actually decrypt, you have to have an unlocked. So in this scenario, this was the first one unlocked, right? This is the first one unlocked. So this can be unlocked by this. This can be unlocked by this. Okay, so let's see this one. This is a 3, 3, 3, 4, 4, 4. So we say this, so this is unlocked, and this cannot be unlocked by anyone because starting from here, none of them is smaller than this. So this can never be unlocked, because you can only be unlocked by things smaller than you. So this can never be unlocked. That's a 0. Which means if we go, right, and we find if this is not a strictly increasing, that's just not going to be possible. Not true, because if I have 1, 2, 3, 2, this can be unlocked by this, right? Yeah. So it's as we go, there must be at least one that's smaller than everybody else. Which means this has to be the smallest. If this is not the smallest, right, and then we have a small, then it can never be unlocked. Yeah, if nothing to the left is smaller than this, which means it's the smallest, so we have to have a smallest. If I have the min here, then it's always possible, because I can always go back to this, right? Then any combination, any permutation of this will work. Oh, we have to do permutation. I'll have to do factorial, mod factorial. I forgot how to do mod factorial. We can just mod. There might be an easier way to do mod factorial. No, I know there's a division has and power has mod factorial. What's the size? 10 to the 5. I guess you just keep multiplying. That's fine. Really? If I go like, so I can use one, let everybody do that, and then I say I'll lock this and everybody do that. Oh, but that's included, right? Huh. order of unlock? I tend to think the answer is just the factorial of this thing. That's my hunch. Because no matter which order that we do, right? So that you can pick, because this definitely has to be the first one. And the second one, you can pick this, you can pick this, you can pick this, you can pick this, right? So once you pick, okay, let's say I pick 4. Let's say I pick 4, right? And then you have 2, 3, 5, right? You have 2, 3, 5. Now, 2 can only be done by this one. 3 can only be done, so you can pick the next one. I can say, okay, let's pick, you can pick 2, you can pick 3, you can pick 5, you can pick anything, right? Because you pick 2, I can use this. You can pick 3, I can use it. You can pick 5, I can use this or use this. But it does not matter. It does not matter. You can pick anyway. So like each position, as long as this is the smallest and uniquely smallest, because if we have another one that's 1, that's also not going to work because it cannot be decrypted. It has to be uniquely the smallest. Then the answer is just going to be the factorial of this. Because in this position, you can pick any one of them, right? And in this position, you can pick any one of the remaining. So I think this is more like a brain teaser. I'm not really a big fan of questions like this. It has nothing to do with coding. Well, if we are right. I mean, I'm not sure if we are correct. I think as long as complexity 0 is the unique min value of all the complexities, the answer is ln complexity minus 1 factorial. Alright, so first we need to say for int I is 1 I smaller than complexity dot size I plus plus. If complexity I is larger equal smaller equal to complexity 0, return 0. Otherwise, factorial, we say int mod is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and int let's go long rest equal to 1 for int I equal to 2 I smaller equal to complexity dot size minus 1 I plus plus rest equal to rest multiplied by I mod, and now I return rest. Alright, let's give this a shot. I mean, these will definitely be right, so I'm gonna just play around. Let's say 4, 5, 6, 7, 8, 9, 10. Okay. Well, we can also, you know, move things around. And then, you know, maybe get some duplicates. You know, 2, 2, 2, 2, 2, 2, 2, 2, 2. 2, 3, 2, 3. Right? I don't know. I'm just 1, 2, 3, 1. Just throw some random stuff at it and see if it stick. I'm getting too many test cases. The last one is now run. Yeah, I think that's most likely that is the answer. Yeah, I think that most likely is the answer. Yep, that is the answer. It's quite stupid. To be honest, I think it's quite stupid. Don't even think I'll upload this. This just feels stupid. Approach. Brain teaser. Like, what the hell? Alright, so yeah, I'm not gonna upload it. Let's just be it. Okay, that's it.